Very good morning, all of you. So yesterday we started with principle of least square. So briefly, I will take a review of this principle of least square and then we will move ahead. So as we discussed that if we have a data points, say x1, x2, sorry, x1, y1, x2, y2, and so on, then we can fit a curve y is equal to a plus bx plus cx square up to kx raised to m. And we discuss how we plot the points on the graph paper, and for the given data point we draw a curve y such that the error between the line and the point should be as minimum as possible, and whatever deviation between the actual point and the point that we get by using that equation, that difference is called as error. So ultimate objective is to minimize this error. And the suppose if we assume the data points which are above the curve are positive and the points which are below the curve are negative, then we cannot directly add those errors. So in order to add them, we square those error and then we take the sum of those, and we will get the total error E. And in least square method, the ultimate aim is to have minimum value of error E, so that whatever predictions we will made by using this equation of y, that will be very close to the realistic solution, or predictions can be made accurately. Okay, so now we will start with the application of least square technique for a straight line. So if you go to the previous slide, yeah, this particular slide, you can see here equation for y. And if you take the bracketed values of the equation, y is equal to a plus bx. So we know that this is the equation of a straight line. If we expand this and if we take additional term cx square, then it will be a second degree parabola. So what we are going to do in this particular session, we will be fitting a straight line y is equal to a plus bx for the given data set. So this particular equation we will consider y is equal to a plus bx. If you open different books, then you may find that y is equal to ax plus b. So different way of writing you will find, but we will be taking this as a equation y is equal to a plus bx. So generally, in order to solve such type of a problem, the values of x and y are generally given to you in terms of x1 y1, x2 y2, x3 y3, xn yn. And what you need to do, you need to count how many data points are there. So in this case, n number of data points are there, so you will get the value of n. Or sometime if there are so many data points, then the value of n will be given to you. If it is not given, you can count the number of data points and you can check what is the value of n. After that, what you need to do, you need to use the normal equations. So in previous slide, we saw the equation for the total error E. Okay, so based on this, there is a long derivation, and after that derivation, we can derive some normal equations. So I will not be taking those derivation, but whatever the outcome of that derivation, we will be seeing that only. So the first normal equation that we use for fitting straight line is summation y is equal to n a plus b summation x. So summation y means in the given data point you need to take sum of all the values of y, and that will become a summation y. Similarly, n we either it is given in the problem, or you will just count the number of data points, that will be the value of n. Again, summation of x means you need to take the sum of all the given values of x, so that will become your summation x. So summation y, n and summation x are known or can be calculated, and there will be two unknowns, A and B. These are the two unknowns. Second normal equation is summation xy is equal to A summation x plus B summation x square. So what you need to do, you need to first of all prepare a column or prepare the value for the product of x and y. So product of x1 y1, x2 y2, x3 y3, and up to x and y1, that value you need to calculate, then take it their sum. So that will become summation xy. Again, we just discussed how to take summation x. Then in order to calculate summation x square, so first of all prepare a column in which the square values of x will be there, and once you prepare that, then take their sum. So this is how you can calculate summation xy, summation x, and summation x square. And again, in this equation, A and B are the two unknowns. So now if you look at equation number 1, then there are two unknowns, A and B, and when we look at the normal equations, we have two normal equations. So two unknowns, two normal equations. Upon simplification of these two normal equations, we can easily calculate the value of A and B. And how to solve these normal equations or simultaneous equation? In unit number 1, we discussed different methods, Gauss-Seidel or Gauss elimination. So these method can be used for solving these simultaneous equations in order to get the values of A and B. Even sometime what we can do, you already wrote a program to solve simultaneous equations. So when you solve the answers manually, you can verify the answer by putting the values in the program as well. So I did the same. And why that is essential? Because when you solve the examples which are given in the problem, many times you find that there is a calculation mistake, and you need to verify whether the answer is correct or not. So again, in that process also the Python program will help you. Then finally put the value of A, B in equation number 1, and ultimately you will get the equation y is equal to A plus bx, where A and B are now known to you. And once you get this equation y is equal to A plus bx, for any value of x, you can calculate the value of y. So this is how you can start predicting the values. So briefly, I will explain the steps once again. So first, the data will be given to you. From that, count how many data points are there. As there are two unknowns, because we are fitting a straight line, so you need to use two normal equations. Then you need to prepare table to calculate the unknowns from the normal equations. Once you get the all unknowns from the normal equation, solve these two simultaneous equation, calculate A and B, put the value of A and B in equation number 1, you will get the required equation y is equal to A plus bx. That can be used for the predictions. Now we will take one example. Fit a straight line passing through the points, and the data points x and y are given to you. So in this particular problem, it is mentioned that straight line you need to fit. The equation of straight line is not given to you. So as we discussed in previous slides, we are taking not this equation, A plus bx we are taking. Okay. So we are taking equation y is equal to A plus bx. But yes, of course, you can also take y is equal to ax plus b. But if we consider y is equal to ax plus b, then accordingly you need to modify the normal equations. So we will follow traditional or the pattern that we discussed in previous slide, that is y is equal to a plus bx. So this will be the equation that we will be taking for the straight line. Then when there is a straight line, these are the two normal equations. Summation y is equal to na plus b summation x, and summation xy is equal to a summation x b summation x square. So two unknowns, two normal equations. Then what you need to do in order to calculate the unknowns, that is summation y, summation x, summation xy and summation x square, we need to prepare a table. And one more unknown is there, that is n. So n means total number of data points. So you can see here 1, 2, 3, 4. So total number of data points equal to 4. So n will be 4. Okay, so we will prepare a table now. So in first column, you need to put the value of x. So you can see 1, 2, 5, 7. So these values we can say see. In second column, you need to put the value of y. So 1, 12, 117, 317. Then nextly you need to calculate summation xy and summation x square. So you can see here summation x square column is there. The square of 1 is 1, square of 2 is 4, square of 5 is 25 and so on. So this is how you can prepare the column for x square. Then next column is xy. So product of 1 and 1 is 1, product of 2 and 12 is 24, product of 5 and 70 is 585 and product of 7 and 317 is 2219. So this is how you can prepare the table. And if you look at the last row of this table, this is the summation x, this is summation y, summation x square and summation xy. So this is how you can find out the values of summation x, summation y, summation x square and summation xy. Then put these values in normal equation. So this is normal equation number 1. So here you can see n is equal to 4, number of data points equal to 4. A and B are unknown. So as it is, summation x is 15. So and summation y is equal to 447. So upon simplification, you will get 4a plus 15b is equal to 447. And let's call this as a equation number 1. Then this is the second normal equation. So summation xy is already calculated. So it is 2829. A is unknown as it is. Summation x is 15. B is unknown. Summation x square is 79. So put all the unknowns in the equation. And upon simplification, you will get 15a plus 79b is equal to 2829. Let's call this as a equation number 2. And now you can see that there are two unknowns, that is a and b, and we have two equations. And these two equations are simultaneous equations. So you can use any of the method that we discussed in unit number 1 to solve this simultaneous equation. And upon simplification or solving these two simultaneous equation, we get a is equal to minus 78.2637 and b is equal to 50.6703. Now put these values of a and b in the equation of straight line. Here you can see y is equal to a plus bx. So put that into this equation and y final equation you will get it as y is equal to minus 78.2637 plus 6703x. So once you get this equation, what you can do, suppose you are interested to know what is the value of y when x is 8. So in this equation you can put x equal to 8 and you can easily calculate the value of y. Again, you may be interested to know what is the value of y when x is equal to 6. So put x is equal to 6 and you will get value of y. So this is how you can start using this equation of straight line for predicting the values. Now, briefly, I will summarize this problem once again. The data points are given into the problem and you need to fit a straight line. Equation of straight line is decided y is equal to a plus bx. So as you fit a straight line, these are the two normal equations in which two unknowns are there. In normal equations, there are some unknowns. So we prepared the table for the same. When you prepare the table, you can calculate the values of summation x, summation y, summation x square, and summation xy. So put these values in normal equations. So from first normal equation, you will get equation number 1. And from second normal equation, you will get equation number 2. And these are the two simultaneous equations. Simplify those equations and you will get y is equal to minus 78.2637 plus 50.6703x. We will see another problem. The experimental data for force and velocity from a wind tunnel experiment is given in the table. Fit a straight line passing through the point. So you need to fit a straight line. So equation is y is equal to a plus bx. And here instead of xy, what is given? V, that is velocity, that is wind speed, we will say, and its unit is meter per second, and the values are given to you. And the force is given in Newton. So again, its values are given. So before you start solving the problem, you need to check whether the unit are appropriately given or not. If they are mismatching, then you need to convert the unit. Otherwise, what will happen later? There will be a mistake in final equation. So Newton and meter per second, yeah, of course the SI units are there and it is absolutely fine for us. Now, here y is equal to a plus bx. Instead of that, we can write equation F is equal to a plus bv. That is, force is equal to a, b, which are unknown, and v is the velocity. So this equation we are preparing for the v and f, as we are told to prepare an equation of straight line. And generally what happens, we can write this equation, but when you start doing calculations, so we are very much comfortable with x and y. So f and v may be confusing to you. So what you can do, if you are very much comfortable with x and y, and why I'm telling this, because since unit number 1, we are always writing the equation in terms of x and y only. So you can assume x is equal to v. So in this equation, you can put v by x and you can take f is equal to y. So ultimately the equation will become y is equal to a plus bx. This we are assuming for our understanding purpose. Then once the equation will be converted to y is equal to a plus bx, then yes, of course, these are the two normal equations. Summation y is equal to na plus b summation x, and summation xy is equal to a summation x, b summation x square. Then again, we need to prepare the table for summation y, summation x, summation xy, and summation x square. So in column number 1, you can see the values of x: 10, 20, 30, 40, 50, 60, 70, 80. All the values of x. In second column, all the values of y: 25, 70, 380, 550, 610, 1220, 830, 1450. And you need to carefully enter the value, because during that entry, you may do some mistakes. So carefully you need to do it. And that's why here also I'm verifying the same. Again, prepare the column for x square. So 10 square is 100, 20 square is 400, 30 square 900, and similarly you can calculate the remaining values for x square. Then last column is xy. So 10 into 25, 250, 20 into 70, 1400, and similarly you can calculate the remaining values and complete the last column, that is xy. And then finally you take the summation of x, summation of y, summation of x square, and summation of xy. So this is how you prepare the values. And even though these values are available in the table, you need to write down because you need to do so many calculations in the hurry. So again, below that table, write down what is the value of summation x, summation y, summation xy, and x square. So these are the values. Then by using first normal equation, you can see n is 8 in this case. A and B are unknown. So as it is, summation x is 360 and summation y is 5135. And upon simplification, you will get 8a plus 360b plus 5135 as equation number 1. Similarly, second normal equation you can see where a is unknown, summation x is 360, summation x square is 312850, and which is equal to summation xy, that is 20400. And when you simplify it, you will get second equation as 360a plus 312850b equal to 20400. And you can look at the equation 1 and 2. There are two equations and two unknowns, and unknowns are a and b. So you can use any method to solve these two simultaneous equations in order to calculate the values of a and b. So upon simplification, you will get the value of a as 673.8331 and b is equal to minus 0.7102. And ultimately we will get equation of straight line as f is equal to 673.8331 minus 0.7102v. So previously we assumed that this is y and this is x. Now we can put the actual value, that is f and v. So this is the equation you get from the for the given data points. Now briefly we will go back. Yeah. So here you can see we got the equation. Now one may be interested to know what is the how much force is exerted when velocity is 45 meter per second. Or somebody may be interested to know what is the force when the wind velocity is 100 meter per second. So such type of predictions can be made by using the equation that we derived. That is this particular equation. Okay. Now we did all these steps manually, right? So we have normal equations. By using that, we prepared table, we calculated the summation x, summation y, that is unknown from the normal equations. Then we prepare equation 1, then equation 2, we solve equation 1 and 2 to get the final equation. But we can also check it with graphical method. So here you can see there are 8 points. So first point is 10, 25. So this is x is 10, y is 25. Second point is 2070. So you can see x is 20, y is 70. Third point is 3380. So x is 30, y is 380. Similarly, you can see all the points are plotted. And the normal equation that you prepared, that will give you this straight line. So we are preparing that equation means when you plot that equation on the graph paper, then you will get this particular straight line. And when you get the straight line means ultimately we calculated the unknown, that is a and b. And this is a and this is b, you can see. And here interesting thing is that this intercept a minus 234.2875, and that point you will observe here. You can see here. So when you extend this straight line here, and the point where it intersects the y-axis, that will be the value of A that you can see here. And generally the value of B is generally decide the slope of the straight line. And you can see the V is on x-axis and F is on y-axis. So this is the graphical meaning of the values A, B, F and V. And once you do it, then you can extend this line to backward as well as forward direction. And you can find out any unknown for any next value of V, or you can find out any value for the values of V which are maybe on this particular side. Okay, so yeah, of course the velocity cannot be negative. That is very practically impossible situation. So it is better to predict the value on positive side, or sometime you can find out the value which may be somewhere here, anywhere. So that can be done. So if you have any question related to this, the session is open for discussion. Yes, any question do you have? Okay, it seems that there is no question. So we will move ahead, and these are the two simple examples, and from these two examples, what you may say that these are very simple examples. Now we will increase the complexity a bit. Now look at this equation. Y is equal to a plus bx square. When we look at this equation, it seems that this is non-linear equation, and we cannot fit a straight line for this particular equation. Then what to do? So things are very simple. You can put x square is equal to capital X, and when you do it and put this value back into this equation, your equation will be y is equal to a plus bx. So this is how you can simplify the equation and convert into a straight line. So this is the another approach to simplify the given complex equation into a straight line. And now you can solve any problem by using a straight line equation. Then you look at this equation, y is equal to ax plus bx square. Again, this also equation looks very complicated and doesn't look like a straight line. So what you can do, you can divide the above equation by x. So when you do that, you will get equation y divided by x is equal to a plus bx, because when you divide this term by x, it will become a, and if you divide this term by x, then it will become bx. Now in this equation, if we put y by x is equal to y, if you do this, then you can see capital Y is equal to a plus bx. So this is how we can convert the given equation into a straight line equation. Let's take another example. Y is equal to ax plus b by x. So for this particular equation, you can multiply the given equation by x. So when you do it, y becomes xy, then b by x becomes b, and ax becomes ax square. Then you can put xy is equal to capital Y, x square is equal to x, b equal to capital A, and a equal to capital B. So when you put those value into this equation will become y is equal to a plus bx. So you can see here, this is the simplified version of that equation. Let's take another example. Equation y is equal to ax square plus b by x. So multiply above equation by x. So y will become xy, ax square become ax cube, b by x becomes b. So put xy is equal to y, small a is equal to capital B, x cube is equal to x, and b is equal to capital A. And when you put all these values in this equation, what you will get? You will get equation of straight line y is equal to a plus bx. So what we did, or what we have seen in this, for example, that sometime it seems that equations are very complicated and we cannot fit a straight line. But when you do operations like this, then it will help you to simplify that equation to a straight line equation that we observed here. And in the examination, sometimes such type of questions may be asked, or even in many practical examples you may come across such type of equations. And what you need to do, you need to convert those equations into straight line in order to solve those problems easily. So that's why we call this as a special type of curves that can be converted into a straight line. Let's take one example. By the method of least square, find the curve y is equal to ax plus bx square that best fit the following data, and the value of capital X and capital Y are given to you. Very interesting thing in this problem is that it is not mentioned that you need to fit a straight line. What they said, you need to fit the curve y is equal to ax plus bx square. So there are two options. First, you may think that this is the quadratic equation that we will be discussing in upcoming classes as well. But here, when you look at this equation, you must understand that this equation can be converted to a straight line. So what you need to do, you need to divide x on both sides. So y will become y by x, ax becomes a, and bx square become bx. So when you do that, the equation will be simplified to y is equal to a plus bx. So you can see here. So this is similar type of example, and therefore we put those values y is equal to y by x, s is equal to capital X, small is equal to capital A, and small b is equal to capital B, and we will get the simplified equation. And again, total number of data points are 1, 2, 3, 4, 5. So 5 data points, so n is equal to 5. So now you have the simplified equation y is equal to a plus bx. Now there are two unknowns, so again the steps are remain same. First normal equation, summation y is equal to n a plus b summation x, and second normal equation is summation xy is equal to a summation x plus b summation x square. Now prepare a table to calculate those unknowns. Now here we need to prepare the table very carefully. So you can see the first column will consist of value of capital X, 1, 2, 3, 4, and 5. Second column consists of the value of capital Y, 1.8, 5.1, 8.9, 14.1, and 19.8. Now, based on the modified equation y is equal to ax plus b and its corresponding relationship with other values, you need to prepare the next column. For example, we are replacing small capital X by small x. So here you can see the small x value will be equal to capital X. So you can see this is just a replica of column number 1, and that's why you can see the values of column number 3 are 1, 2, 3, 4, 5. Then we know that small y is nothing but the ratio of capital Y by capital X. So take the ratio of capital Y and capital X to prepare the fourth column. So you can see the 1 divided by 1.8, answer is 1.8. 2 divided by 5.1, it will be 2.55. 8.9 divided by 3, you will get 2.9667. Similarly, you can calculate the remaining values of small y by taking the ratio of capital Y upon capital X. So this is very important. Again, in next column, you need to calculate the values of x square. So just take the square of the small x. So square of 1 is 1. Similarly, the square of 2 is 4, square of 3 is 9, and so on. Then in last column, you need to take the product of small x and small y. So 1 into 1.8, you will get 1.8. 2 into 2.55, you will get 5.1. Then 3 into 2.9667, you will get 8.9, and similarly you can prepare the calculate the remaining values. Many times what happens, students make mistakes in the symbols, so they get confused between the capital XY and small xy. And here, especially in this particular column, instead of small xy, if we take the product of capital XY, then you will get a different values, right? And your answer will be wrong. So there are two choices you may have. Carefully write capital X, small x, capital X, small y, capital Y, carefully at each places. Or instead of small x, small y, you can go for another notation. For example, PQ, that also we use commonly. So here instead of y is equal to a plus bx, you may think of taking q is equal to a plus b small p, so that this x will become p and p will be x, small x will be p, and the capital small y will become q. So this is how you can make your own strategy. Otherwise, the notation with which you are comfortable, you can go ahead with it. Okay, so once you prepare all these columns, and here in this type of problem, student may mistake while making the column. So be careful about preparing the table. Do not get confused between the notation and their corresponding relationship with other value. Then we can get the value of summation x 15, summation y 14.8017, summation x square is 55, and summation xy is 49.7. So this is how you can calculate. Now put all these values in normal equations. So these are the values. Then put these values in first normal equation, where summation y is 14.8017, n is 5, a and b are constant unknown, so as it is, summation x is 15. Upon simplification, you will get 5a plus 15b plus 14.8017, that is called as equation number 1. Then use a second normal equation. Summation xy is 49.7, a and b are unknown, summation x is 15, summation x square is 55, and upon simplification you will get 15a plus 55b plus 49.7. Let's call this as equation number 2. Therefore equation 1 and 2 are two simultaneous equations. You can solve it to get the value of a and b, where a is 1.3719 and b is equal to 0.25. And now you need to do the back substitution, because a small a is nothing but capital A and small b is equal to capital B. So this is called as back substitution. and when you do that, you will get capital Y is equal to 1.3719 capital X plus 0.5295 x square. So this is how you can solve the given problems. So that's it for today's session. If you have any question, the session is open for discussion.